Welcome back to our next lesson. Today we're going to take a peek at rectangles with equal area, which is on page 132 in your textbook if you're following along. Last time we did exploring rectangles with equal perimeters, so now we're just going to do the flip side of that, equal areas. I actually think this one is a little bit easier, so hopefully you find the same thing. We're just going to get started with some dot paper, which hopefully you were able to download and print off. Okay, I've already got a little table on mine. Don't worry about that just yet. So on page 133, there's an example where they get you to draw all the possible rectangles with an area of 16 centimeters squared. Okay, don't forget about that squared when we're doing area. Make sure you can see that all the way. So that's what I'm going to do. I'm just going to break down how you would find all the possible rectangles that have an area of 16 centimeters squared. Like I said, it's super easy. We're actually going to start by drawing rectangles the same way that we drew them when we did perimeter. So by doing a width of 1, and then doing a width of 2, doing a width of 3, doing a width of 4, and so on until you're finished. That makes it really easy, really straightforward for drawing, and then we'll do the formula work afterwards. Alright, so for a rectangle with a area of 16 centimeters squared, I'm going to start by doing a width of 1, just like that. Now it's just a matter of counting out the squares. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. My goodness. Long, skinny rectangle there. Pop in my lines to break up the squares. Alright, so that's the first one. Okay, so we've got a width of 1 and a length here of 16. Now if you remember back, I used a little formula for calculating perimeter. Hey, we're just going to keep track of the perimeters as we go. So I've got a length of 16, a width of, not W, a width of 1, 16, 1, which gives me an overall perimeter of 34 centimeters. Fantastic. Okay, now we're going to go from a width of 1 up to a width of 2. I'm going to try to save a little bit of space. And all I have to do is just count on by 2. So we've got 2, 4, 6, 8, 10, 12, 14, 16. So this is my second rectangle with an area of 16 centimeters squared. Alright, do the same thing for perimeter. Length plus width plus length plus width, which is equal to, this is 2 and this side is 8 if you counted it out. So we've got 8 plus 2 plus 8 plus 2 is equal to 20 centimeters. Done. So we've got 2 rectangles done. Right on. Move on to a width of 3. 1, 2, 3. Okay, same thing. We're going to count on. So we've got 3, 6, 9, 12, 15. Well, if I count on by 3s, the next number I'm going to get is 18. So this one is looking like it's not going to work. If I want an area of 16, I'm going to have to do this. Now, will we do shapes like this eventually? Yes, but we are looking at equal areas for rectangles. This is not a rectangle. It's a shape, but it's not a rectangle. So this does not work. Okay, we cannot use that one. So now we're just going to move on to 4. Hopefully 4 works. 1, 2, 3, 4. Good, just barely fits on the paper. Count on by 4s. 4, 8, 12, 16. Easy peasy. Break up my squares. Alright, so we've got a width and a length of 4, so we got perimeter is equal to length plus width plus length plus width, which is 4 plus 4 plus 4 plus 4, which is equal to 16 centimeters. All right. So same as dealing with equal perimeters, when you reach a square shape, in this case it was exactly a square, we've got 4 equal sides, I'm done. I know I found every single possible rectangle when I hit a square. Because if I go to the next one, 5 isn't going to work, 6 is also not going to work, 7 is not going to work. It's going to bring me to 8, which is this rectangle again. Alright, so I'm going to take all of this information. We have 3 rectangles, and I'm going to pop it into my table up here. Length and width are interchangeable. I always do width as the smaller side. I couldn't tell you why, I just do. But you can swap them out if you wish. So we have a width of 1 and a length of 16, a width of 2, and a, where am I looking? There we go, 8, and a width of 4, length of 4. Alright, that area is going to be all the same at 16 centimeters squared. Okay, I got my units up here, centimeter, 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 centimeter squared. And then my perimeters are 34, 20, and 16. Alright, that's pretty close to it, but we're going to do a couple extra things here. One of the questions that you're going to get, similar to when we're looking at equal perimeters, is saying, alright, I give you a certain area, I want the biggest possible perimeter, I want the smallest possible perimeter. So it's kind of helpful to know the kind of shape that you're going to look for if you want a big perimeter or a small perimeter. So if you have a long skinny rectangle like this one down here, okay, or this, if it's long and skinny, right, it's going to have a really big perimeter, right? If it's more square shaped like this one, or you can just kind of see the top of it right there, if it's more square shaped, it's going to have a smaller perimeter. Depends on what kind of question you run into, where if that'll be important or not, but it's just one thing to keep in mind. Long and skinny, big perimeter. Square, short and square is going to be your smaller perimeters. All right, let me grab one more piece of dot paper. So where do the formulas come into play here? So when we're looking at area, we're looking at area equals length times width. If we're looking at perimeter, we're looking at width plus length plus width plus length. See what I did there? I swapped them. I usually do length plus width. Doesn't matter. Okay, it all works the same. If you get really comfortable, really good with these formulas, you're going to be able to solve these questions a lot faster than having to draw the rectangles out every single time. The more you can do in your head, the better. That's where these tables are going to come in really handy. Okay? Being able to use something like this to say, all right, I need an area of 16. Well, I'm going to go 1 times 16, 2 times 8, 4 times 4. That's really, really, really handy. All right? So as an example question here, okay, I'm not going to draw any rectangles, I'm just going to use math. Okay, if I say, all right, I need a rectangle that has an area of 16 centimeters squared. Perfect. I know my brain goes right away, I need a 4 by 4. Okay, because I'm going to use this formula up here, area equals length times width. Well, not so fast. If I say I need a area of 16 but a perimeter of 20 centimeters, my go-to, like I said, would be, alright, I'm going to use length times width, and I'm going to do 4 times 4, and that's going to give me an area of 16 centimeters squared. Awesome. But if I'm asking for a perimeter of 20, that might not work. Because if I do my perimeter formula, I get 4 plus 4 plus 4 plus 4, and that gives me a perimeter of 16 centimeters. So all of a sudden, that doesn't work anymore. So I need to think of 2 other numbers that multiply to 16. Okay. but if you put them together using our perimeter formula, they're going to equal 20. So this is where knowing your basic facts is going to become very, very, very important. Now, we've already done all the rectangles for 16, but you need to be able to think, all right, well, I know that 1 multiplied by 16 is 16. Okay, I know that 2 multiplied by 8 is 16. I know that 3 multiplied by nothing, because 3 doesn't work. 4 multiplied by 4 is going to give me 16. Alright, so that's going to solve the area side of it, but with perimeter, I've got to look at these numbers again and see, okay, I need 2 of these and 2 of these, because we've got length plus width plus length plus width. Well, 1 plus 16 is 17, plus 1 is 18, plus 16 is, oh, okay, that's way too much. Okay, we already did 4 over here. But if I look at my perimeter formula and I get length plus width plus length plus width, alright, I've got an 8 plus a 2 is 10, plus an 8 is 18, plus a 2 is already, I've got 20. Right, so for a question like this, with the 16 and the 20, we've already done all those, so this may seem like common sense, but if you go through your textbook and you look at some of the questions they ask where it says, number 4 for example, an area of 20 and a perimeter of 18. Okay, an area of 18 and a perimeter of 22. An area of 2 and a perimeter of 6. If you have to draw every single set of rectangles to figure out just what the one rectangle you need, that's a lot of extra work. Alright, so if you can start doing this work here where you know the formula for area and you know the formula for perimeter, you can do some simple math trial and error to get to your correct answer fairly quickly. If you are more comfortable just drawing rectangles right now, that's also totally fine. That works. This is what you want to work towards being able to do, because when you get to really big numbers, okay, like you will in grade 6, grade 7, if I ask you to find a rectangle that has an area of 36 and a perimeter of 74, for example, do you want to draw that? Okay, do you want to draw a rectangle with a perimeter of 74? Probably not. Okay, that's a very, very, very big rectangle, but if you can start doing the math quickly, you can save yourself from drawing really big rectangles time and time again. So, on your practice questions, page 133, 134, okay, we'll get you working on those. Try out numbers 1, 2, 3, 4, and 5. Okay, they're pretty straightforward, pretty easy. I will go over them with a review video, and you can double check that you understand everything, that you got them all correct, and it serves as a little bit of a bonus lesson. So hopefully that makes sense, and we'll talk to you again soon.